Okay, hello everyone. I'm going to do calculus and go over it. I'm going to try to teach it briefly but properly. Okay, I've seen some other videos where people are trying to do it briefly, and I don't think they're actually doing it very well, and sometimes they're leaving out very critical things. So there's two types of calculus: differentiation and integration. Okay, generally integration is harder. The differentiation is actually pretty easy, but this can be much harder. Okay, the general formula for differentiation is, if you have equation y equals x to the n, so dy by dx, which means a small change in y by a small change in x, is nx to the n minus 1. Okay? So, for example, y equals x to the fifth, so dy by dx is equal to 5x to the 5 minus 1, which equals 5x to 4. Okay? I should say this is also equal to y dash y dot. Okay? You'll see that in textbooks. Okay, another example. So if y equals x to the 4 plus 3x minus 4, so y dash equals 4x cubed plus 3. Okay, so you notice that becomes 0. That's because y equals x, the derivative of x is 1 because of the symbol for the differentiation is dy by dx. It's with respect to change in x, which is a constant. So it's difficult. You have to explain the theory of this to explain it properly, but it basically becomes 1. And y equals a constant, say like 6. dy by dx equals 0, okay? Because the gradient represents the slope, okay? This isn't a constant, it's a variable, but the derivative is equal to 1. Okay, so another example, y equals x to the 8 minus 3x, okay? So dy by dx equals 8x to the 7 minus 3. That's using this formula, remember? So the n comes down, and you take minus 1 off the n, okay? Take 1 off the n up there, and the n comes down. So you get 8x to 7 minus 3, okay? But what does this mean? What is this? Okay? Well, it actually equals the slope or gradient, okay? Which I should quickly explain. Other videos I've seen, they don't elaborate on this, which is really, I think, bad, because you have a simple equation like that in a straight line. The slope is given by m is the slope, so this normally is y2 minus y1 divided by x2 minus x1. Okay, so you have the y coordinate here, y2 y1 x2 x1. So you got y2 minus y1 divided by x2 minus x1. That gives you the slope. Okay, but you can't apply this to curves. Okay, so I'll explain what this is about, okay? You have a give you a point there, okay? And you have after a ruler and a tangent, okay? Okay, so when you work out dy by dx, you're actually working out the gradient or slope of the tangent at the point on the curve, okay? You're working out the gradient of the tangent here at the point in the curve. The tangent, the point there is the only point where it touches the curve, okay? That's why it's called a tangent. Is that the point there is the only point in which that line crosses, makes contact with the curve. So you're working out the gradient of that point at that point, which is equal to the gradient of the tangent, okay? The gradient at that point is equal to the gradient of the tangent, and that's what dy by dx is equal to, okay? A proper explanation of this requires a much more complicated technical description, which I'm not going to go into here. So, other derivatives, derivative of sine x, y dash equals cos x. And if sine is cos x, y, the equation is cos x, derivative of that equals minus sine x, okay? I think y equals tan x. I think the derivative is equal to the secant squared x, I think. So there's also other ones. Y equals e to the x, y dash equals e to the x, y equals a natural log of x, y dash equals 1 over x, okay? So these are important derivatives to note, okay? This is actually called the derivative. That's called the derivative, whatever it is, okay? So if you have x to the sixth plus e to the x plus log x, that equals 6x to the fifth plus e to the x plus 1 over x, okay? Differentiation is easy, you just apply the integral. Okay, whatever the function is, you just integrate it using the formulas given, or the general formula for it, okay, which I gave you at the beginning. Okay, integration. So this is the reciprocal of dy by dx, okay? And it's harder. Okay? So the general formula, you have so y equals x to the n, so the integral of x to the n dx is equal to the x to the n plus 1 over n plus 1 plus c, which is the constant of integration. Okay? This thing actually stands for summing, okay? It's summing, adding up, okay? So that's the general formula, okay? which you the general formula. So applying it, so I actually made a previous video but I felt it wasn't quite good enough, so I'm redoing it because some errors that went along with it. So if y equals x to the fourth, so you want to integrate x to the fourth dx, okay? By using the general formula, you get x to the 4 plus 1 over 4 plus 1 plus c, which equals x to the 5th over 5 plus c, okay? Now, integration is harder because you have to check back, okay? You need to check. Check the answers. Okay? So you do that by differentiating back. Okay? If this is correct, you should end up back with the original x to the fourth, okay? So your y equals basically 1/5 x to the 5th, okay, plus c. So y dash equals the formula, remember, so phi comes down, so you get 5 times 1/5 x to the 4th, okay, plus 0. 5 times the 5th is 1, so you get, okay, which equals x to the 4th, okay? So that's a check. Always differentiate after you've integrated, because you don't know this is correct. If it's correct, you'll get back the original equation, okay? Another example. So if you have the integral of 2x to the 5th dx is equal to, applying the general formula, 2x to the 6th over 6 plus c, okay? So 2 goes into once, 2 goes into 6 3 times, okay? So you get x to the 6th over 3 plus c, okay? So to check, okay? So if you write that as y equals x to the 6th over 3 plus c, which is a constant number, so y dash equals this is basically a third times x to the 6th, okay? Maybe I'll write it like that. So whether you write dash or dot or this, it doesn't matter, it's always the same meaning. So 6 comes down, 6 times 1, 3, x to the 5th, okay? Plus 0. 3 goes into 6 twice, okay? 3 goes into 3 once, 3 goes into 6 twice. So you get 2x to the 5th, okay? Which is what we start off there originally, okay? So that is correct, okay? Right, so I've done integrating. I've shown you, what have I shown you? I've shown you the basic general formula. Okay, now some other integrals. So you got integral of e to the x. Well, derivative of e to x was e to the x. The integral is also e to the x. Okay. The integral of 1 over x dx. The derivative of log of x is 1 over x. So the integral of 1 over x equals log x. Okay. Plus c, okay? Mustn't forget those. So yeah, the derivative of e to the x is e to the x, integral of e to the x, e to the x. The derivative of log of x is 1 over x, the integral of 1 over x is log of x plus c, okay? The explanation of dx I'll come to briefly in a minute. The integral of sine x dx, so the derivative of cos is minus sine, the derivative of sine is minus cos x, okay, plus c. And the integral of cos x dx equals sine x plus c. Derivative of sine is cos, so integral of cos is sine plus c, okay? So these are formulas to note, okay? So examples of this being used, you have integral of sine x plus x to the fourth dx, you get integral of sine is minus cos x, so okay, so sine is minus cos x. We just combine those into minus cos x plus x to the fifth over 5 plus c, okay? If they're just two numbers, you can just call it 1c, okay? Now I mentioned you have to check it, so I'll check it. So if y equals minus cos x plus x to the fifth over 5 plus c, y dash equals derivative of sine is cos, derivative of cos is minus sine, so the derivative of minus cos is sine, okay? Okay, so I said the derivative of sine is cos, derivative of cos is minus sine, so the derivative of minus cos is sine, so it's sine x, derivative of, that's how you write derivative of cos is minus, what am I trying to do here? Derivative of cos, derivative of cos is minus sine, so the derivative of minus cos x equals, so I said derivative of cos is minus sine, okay, that's a negative sign there. So the derivative of the negative is going to be the plus version, okay? Plus 5 times 1/5 x to the fourth plus 0, which equals sine x, 5 times 1/5 is 1, plus x to the fourth, okay? Which is what we start off here. The equation was sine x plus x to the fourth, okay? And by differentiating the answer, I've ended up back with the original equation. So that answer is correct, okay? Follow that. Integrate that, you get this. Differentiate this, I got back to the original answer. So therefore this is correct. You must always check integrations by differentiating back, okay? Okay, but what is the integrals of x cubed? What does it mean? Okay, so the meaning of it is this. If you have a curve and you integrate in between, normally integrate between two regions, you're actually working out the area, okay? So this is very simplistic. A proper explanation is more technical, but it's very simplistic. When I call this sum, you're actually dividing the strips, okay? And you're summing up the strips, okay? It can also be, it can do volumes as well, okay? So if you have x, y, z, so you might have a shape like that. Okay, so it's a circular rim. So it's for working out volumes, okay? So yeah, if you want to practice a bit of all this, so you got y equals e to the x. What's that equal to? Or the yeah, y equals e to the x. So what's the derivative? Okay. Or integral of 1 over x dx. What's that equal to? Or the integral of x to the 5th dx. What's that equal to? Okay. I will now pause, now explain it. So, derivative of e to the x, okay? Okay, integral of 1 over x, okay? So, that equals log of x plus c, okay? And what's the integral of x to the 5th? Okay? Equals x to the 6th over 6th plus c, okay? The integral of that one is equal to this, okay? Thank you.